So one of the defining characteristics of human languages is ambiguity. Here's an example that linguists are particularly fond of. I saw a man with a telescope. Now, this sentence has two interpretations. In the first interpretation, I used the telescope to see a man. But there's another interpretation where I saw something, and that something was a man who had a telescope. So one sentence, two different interpretations. How do humans disambiguate such sentences? Well, you can use different strategies. You can use linguistic context. You can use world knowledge. We're going to use perceptual context. Now, what do I mean by perceptual context? I mean something like this. So now that we see that Danny is holding a telescope, he's using it to look at Andre, we know that the first interpretation is correct. On the other hand, if we see Andre with the telescope, then we know that the second interpretation is correct. And this is essentially a new task that we're introducing that's called grounded language disambiguation, where you get a sentence, you get several potential interpretations for this sentence, and you're given a visual context that depicts one of those interpretations. And then the task is to choose the right linguistic interpretation given the perceptual context. So this is really a fundamental task for language understanding, in particular for language acquisition, where much of the linguistic input of the child is ambiguous, but it refers to its immediate visual surroundings. It's also really important for visual understanding. So a lot of people these days are doing caption generation, but if you use language as a medium for expressing visual understanding, generating a caption, "I saw a man with a telescope," for this kind of image is just not enough. So if you want to demonstrate that you really understand what's going on visually, you need to be able to provide this deeper linguistic structure. And the kind of visual processing that is required here is really involved. So we need to be able to identify who is there, who is whom, what are the objects, who is manipulating them, who is looking where, and then take all these pieces together and combine them in a compositional manner such that they can be matched against the interpretation of the sentence. So in order to address this task, we're releasing a new data set, which is called LAVA, Language and Vision Ambiguities. It has ambiguous sentences from different types of ambiguity, syntactic, semantic, and discourse ambiguities. And we have videos that film all the possible interpretations for each one of the sentences in the corpus. We also have a model that addresses this task, and it's an HMM-based model that is able to represent and score sentence interpretations against videos. And this model is doing pretty well on our dataset. So to summarize the contributions of this project so far, we're introducing a new task, disambiguating language using vision. We're releasing a new data set that enables to study these kind of tasks, and the model that obtains preliminary results on this kind of problem. And for more details, I invite you to look at the paper below.